Today we're going to learn about the standard normal curve. Our goal, estimate areas under the standard normal curve. We've learned about finding areas in the past and what are they related to? Think back. When you find the area, you're also finding something else. Do you remember what it is? The probability. So area is the same as probability. In other words, how likely is something to happen? Let's take a look at our normal curve for a second. If you look at all of the space under the curve, what's the area of that? Well, that's going to be 100%, right? That is 100% of the space underneath. So there is 100% chance that the data is going to fall under the normal curve of the data collected in our examples today. Okay, let's go ahead and find out how we're going to find these areas to ultimately find the probabilities. You will need the standard normal curve handout. Now, if you don't have access to this handout, you can always Google standard normal curve table. It's quite long because it goes all the way from -3 to +3, like we see on our standard normal curve, in decimals. Okay, we're going to use that today. You absolutely need that to help you answer these questions. So let's do it now with an introduction to when do you need this table and how do you use it? Well, you need this table when you're given a z-score that's a decimal, or it has decimals in it, I should say, and you're asked to find the probability. Okay, so let's use an example and go through these steps. Let's say you're given a problem where they want you to find the probability, and you're told that the z-score is -2.77. So step one's done. You looked at the z-score in your problem, identified. Step two, look in the column on the left for the whole number and the number in the tens place of the z-score. So we're looking for this whole number and this number in the tens place. On the left column, -2.7 is right there. So what we're going to do is highlight that entire row. If you can't highlight, you can visually highlight or circle, print it out, however you see fit. Step two is done. Step three, look in the row on top, so circled in red, for the number in the hundredths place of the z-score. So here we see 7 in the hundredths place. So we're going to look across until we find 7 in the hundredths place. There it is. And highlight that column. And where they overlap or intersect is the probability. So a z-score of -2.77 has a probability of 0.0028. Meaning it's very unlikely, and that makes sense, right? Because we learned before that a z-score of -3 is way over here. So -2.77 would be right about there, meaning this little bit of information out of the whole thing. That is a very, very small amount, right? Makes sense. All right. Go ahead and practice using your table to find the probabilities of these z-scores. Z-scores given have decimals in them, so we need to use our table. Okay, let's see how it went. First, whole number and tens place. 0.5, and then 4. There it is. Should have gotten 0.7054. Next, I'll just keep the highlighting, use different colors. Here we go. 0.1 all the way till we get to 3. There it is. And 0.3 till we get to 0.08. 0.6480. Take another look to make sure you really understand how these values were found, because you're going to need to have this skill down. And here we go. The expression, the probability of z being less than negative 2.02, represents the area under the standard normal curve to the left of a given value of z. This is super, super important. Write down what's in red here. The areas, also known as the probabilities that you're seeing in those tables, only tell you the probability to the left. Okay? Make sure you're aware of that. You will need to know that very soon. Not for this problem though, because they asked us specifically to find the area to the left, which also makes sense, right? Because a z-score of negative 2.02 is right about here, negative 2.02. And they want the z-score less than negative 2.02. So right here, this highlighted region, well, that's exactly what those table values give us. So go ahead, use your tables to find out, is it A, B, C, or D? Okay, hopefully you found the answer to be C. And that also makes sense because that is a very small probability. As a percent, that would be 2.17%. And that's true. That makes up a very, very small portion of the entire area under the curve. Okay, so that's an example where we're asked to find the area to the left. But what if you're asked to find a specific area in the middle, like this? It's nothing we can't handle, and you've actually done something like this before in this class not too long ago. Let's see how it goes. The expression we see here represents the area under the standard normal curve, once again, between two given z values. So our z values are between negative 1.33 and 1.59. Notice they're labeled on my graph. And you want to use your standard normal table, again, to find the indicated area. If it helps you, you can sketch out a standard normal curve with the appropriate area shaded, just like I have here, and label it. Don't have to do this, but I think it might help, especially in this problem, because it's really about shapes. Okay, so let's talk about shapes for a second. Think back to the trapezoid. Do you remember how we found the area? Well, of course, there's a formula, but think about just the shapes. I think it looks something like this. Not quite close. It looks more something like this, where the trapezoid is this shape. And we were trying to find out, how do I find that area? Well, you could use the formula for a trapezoid, but what was the other way? If you think back, we said you could take the area of the bigger triangle, and you could also find the area of this smaller triangle, and you could subtract them to find the area of the trapezoid. Remember that? So similarly, we could take this entire region to the left of this vertical line, let's make it nice and clear, this vertical line, and you could find that area, and then you could also find the area of this yellow highlighted shape. And you could subtract that to get the area of our shaded blue area. Of course, there is no formula for these shapes because these are very unique, but we can use that same logic. Let's go ahead and do that now. Okay? So first things first, find the area, or in other words, the probability, right? That's how they're wording it, probability of the z-score being 1.33. Sorry, negative 1.33. What's that? If you look at your table, let's see. Negative 1.33, there it is. 0.0918. Okay. Then the probability of our other z-score given, which was 1.59. Let's look at our table. Can you find it? 1.59 all the way over. 0.9441. Okay, which was which? Well, this z-score shows us the bigger area from here all the way over there. That's the bigger shape, right? So of course, we're subtracting the smaller area from the bigger area. So to find the answer to our question, you're going to take the bigger area and subtract the smaller area. And what do you get? Let's see. 0.9441 minus, we get 0.8523, or as a percent, 85.23%. And before we move on, we want to be sure that makes sense. So look at the blue shaded area and ask yourself, does that look like about 85% of all the space under the curve? I would say so. All right, we're in good shape. Let's go ahead and practice another one. This one is also a little bit different. Okay, so let's recap. This, we found the probability to the left. This was the probability trapped between two x values with none of the shaded region going all the way to the left or all the way to the right. Did not happen. Now there's something different happening. We're finding the area or the probability to the right of the z-score. Let's see how we do it. A brand of headlamps has a lifespan that is normally distributed with a mean of 1000 hertz and a standard deviation of 80 hertz. Find the probability that a randomly selected headlamp lasts at least 932 hours. Like I said a moment ago, at least means you want the probability greater than or equal to that z-score. But did they give us a z-score? No. How do we find a z-score? Well, they give us a raw score, didn't they? What's that? 932 raw score we indicate with X. If only we knew how to find a z-score given a raw score. You do, of course. You've used this formula. It should be in your notes. Let's go ahead and remind ourselves z equals raw over or minus mean over standard deviation. So raw minus mean, they told us 1,000. Okay. Over standard deviation 80. Interesting. What do you see right away? I see a negative z-score. So you do some calculator work to subtract and divide. We're going to get negative 0.85. That's the z-score. Let's keep everything clear in our minds, okay? Now we know the z-score, so we need to use it and the z-score probability tables that you've been using to find the probability. So go to your tables, look for negative 0.85, and we're trying to find the probability. Matter of fact, go ahead and answer 2 and 3 for yourselves. And I'll show you in a second. Okay. So that z-score relates to the probability of 0.1977. And this is where you really need to think about what's happening. Since we want the probability greater than or equal to, we're subtracting it from 1. That's the key difference here, right? Because think about it. If you want this entire shaded region to the right, you take the entire thing, 1, and subtract this part that I'm highlighting in blue, right? Because that's the probability that the table gives us, right? This little probability there, the table gave us, so we can use that to now subtract to find the larger area to the right, and that is 80.23%. Okay. We're going to practice a little more to make sure we get this down. The scores on a standardized test are normally distributed with a mean of 500 and a standard deviation of 100. Sophia scored 632 on the test. What percent of students scored below Sophia? Round your answer to the nearest hundredth. Since we've solved problems very similar to this, again, I'm going to give you time to practice. Is it A, B, C, or D? Let's see how you did. If you said A, you're getting this. Good job. If not, that's okay. Just practice. Okay, let's go back to the question. What percent of the students scored below Sophia? What percent? So we've been looking at those tables all day, and you know you can use the decimals there to then move the decimal over and find the percent. But we need a z-score, right? Because why? Why do we need a z-score and not a raw score? Because they gave us the raw score, right? That's the thought process. They gave me the raw score. Okay, so I use the z-score formula, find the z-score, plugging in all the necessary parts, subtract, divide, we get 1.32. Remember, this is the z-score. This is not your final answer. They want a percent. So you take your z-score and go back to looking at your tables to find the associated area, aka probability of 0.9066 or 90.66 as a percent. So she did really well, right? I would say so. And our exit ticket for today, what's the value of the probability of z being greater than negative 2.05? The answer is C. Once again, you need to use the table. Remember the process. You go to the column with negative 2.0 and the row with 0.05. And here you will find this value, 0.0202. Remember what they're asking you. They want the value of this. This is the probability of the area to the left, right? But they want the probability that z is greater than, so we're talking about a z-score way over here, and they want this area, not the area to the left. And since the table doesn't give that to us, we need to once again subtract. So just take 1, which represents the entire area, subtract the little piece over here you don't want, to then find the area of the big piece you do want. And that's how it's done. That's all for now. Until next time.